Good morning, students. Today we will talk about dual nature of matter and radiation. Okay, so it is the part of BSc part first inorganic chemistry, and this topic is dual nature. Means the electron shows two types of nature, that is in particle form and in wave form. Okay, so first of all the microscopic material like electron, proton, atoms in motion possesses both the particles and wave characteristics. This behavior is known as dual nature proposed by Debroglie. Wave associated with matter is called matter wave or Debroglie wave. Means कि हम यहाँ पर देख रहे हैं कि माइक्रोस्कोपिक मटेरियल, जितने भी छोटे एलिमेंट्स, जितने माइक्रोस्कोपिक मटेरियल्स होते हैं उसके अंदर क्या होगा, जैसे इलेक्ट्रॉन्स हैं, प्रोटॉन्स हैं, एटम्स हैं, मॉलिक्यूल्स हैं, इनके अंदर क्या है कि ये जब मोशन में होते हैं तो मोशन में ये मोशन में ही होते हैं, तो मोशन में होते हैं तो ये दो टाइप के करेक्टरिस्टिक्स शो करते हैं, as particle wave and as well as wave characteristics. Okay, so this behavior is known as dual nature. Okay, और ये दिया किसने था, डी ब्रोगली ने दिया था. एंड ये जो वेव है इससे जुड़ी हुई जिसके बारे में हम बात करेंगे वो वेव डी ब्रोगली वेव जो है उसको कहा जाता है. ओके, सो what is de Broglie relations? De Broglie's relation or dual nature, we must know that lambda is directly proportional to mv, and what is m and v is moment of particle. Okay, and lambda is the wavelength. Okay, so we can write lambda is inversely proportional to 1 upon mv, and in spite of mv we can write p, and here de Broglie principle states that wavelength of matter wave is inversely proportional to momentum. Okay, from here the de Broglie principle states that wavelength of matter is inversely proportional to the momentum. So according to this is the formula of de Broglie relationship or dual nature. Okay, so after that we will do some questions related to de Broglie momentum or de Broglie theorem. So first question is that is given, calculate the momentum of a particle which has de Broglie wavelength of 0.1 nm. So given is h, which is Planck constant, 6.6 into 10 raised to power minus 34 kilograms meter square second inverse. So what is the solution? The solution is, first of all, in any numerical we see what is given, and given is lambda 0.1 nm. So we convert it in meters. Okay, because the Planck constant is in mks, so we convert in meter. So because we know that nanometer is equals to 10 raised to power minus 9, so 0.1 nm into 10 raised to power minus 9, so it will be 10 raised to power minus 10 m. Okay, so we know the formula lambda is equals to h upon p. Here h is Planck constant, so p will be h upon lambda, and we can write value of h which is given and value of lambda which is also given, but we convert it into meters. Okay, and we will get the momentum of electron. Okay, so this is first question related to your examination. Second question from de Broglie theorem can be this: calculate the kinetic energy of a moving electron which has a wavelength of 4.8 pm. Now, as we do earlier, calculate the kinetic energy. First of all, what is kinetic energy? We know that kinetic energy is half mv square. And for which particle? Electrons. For electron which has the wavelength is given, lambda is given 4.8 pm. This is picometer, and picometer means 10 raised to power minus 12. So 4.8 into 10 raised to power minus 12, जैसा कि हमने पहले भी किया, and then m. Why m? Because kinetic energy is half mv square, and we know the m, mass of electron, because it is electron, and in this formula हमें क्या चाहिए? m चाहिए. इसका मतलब हमें m पता होना चाहिए. किसका m? इलेक्ट्रॉन का, वो हमें पता है. सो इन m केस हम इसको यूज़ करेंगे, तो 9.1 इंटू 10 रेज टू पावर माइनस 31 kg, and Planck constant is 6.6 into 10 raised to power minus 34 joule seconds. So we know that the formula of de Broglie equation is lambda is equals to h upon mv. So v is equals to h upon m lambda from this equation. Okay, so in this equation we calculate v. Okay, so Planck constant is this. So first of all we should know that the Planck constant value in mks, okay, or joule second. So mks, in mks we will write the value of h or Planck constant, and upon m because electrons mass is 9.1 into 10 raised to power minus 31, and the value of wavelength as given in numerical 4.8. so we convert in meters, so 10 raised to power minus 12, multiply it with it, and we get v. Okay, v is here. Now what is in question? Calculate kinetic energy. So kinetic energy, we know that half mv square, m we know that 9.1, and v we already calculated the the value of v, 1.516 into 10 raised to power 8 is a second inverse, and this is the answer here after calculation. So we can calculate the potential energy of electrons. After that, what is the third type of question you will see in your examination? Calculate the de Broglie wavelength of an electron at 1% of speed of light. You know the speed of light as c is equals to 3 into 10 raised to power 8. Okay, and 1% means we should calculate the 1% of this. So 1% of this means 3 into 10 raised to power 8 meter second inverse and into 1 upon 100. So we get this value of C, or you can say V. Okay, here the value of C, we replace it with V. Okay, and as we know that the momentum P is equals to m into V, and we calculate the momentum. After that we get P. So in the calculation, in the numerical, the given is calculate the lambda wavelength. Okay, so lambda is h upon P, and we have already calculated the value of P. So we put it in this formula and we get this answer. So these type of questions you will see in examination. Now one different type of question which is important, that what would be the velocity of electron with respect to proton. Okay, electron it equal to proton, and he is asking about, the examiner is asking about what would be the velocity of electron with respect to proton when wavelength associated with proton. Okay, so we know that mass of electron is 9.1 into 10 raised to power minus 28, and mass of proton is 1.6 into 10 raised to power minus 24. So after that we get as per Debroglie equation, so lambda is equals to h upon m into V, and lambda E is equals to h upon me into ve, because we know only one formula. So for electron it is lambda E, and for m mass of electron, and on velocity of electron, and lambda means wavelength of electron. Okay, so in this P, for proton, lambda P is h upon mp Vp. So in this we know that lambda E is equals to lambda P, because in the question, in this question, lambda E is equals to lambda P. So we will equal this formula and get me, because h and h cancel, and MEVE is equals to MPVP, and from here VE is equals to MPVP. ये ME इधर आ जाएगा, and then we put the values and get the value of VE is equal to 1836 Vp. Now according to this formula, you should also learn this, because according to this formula you will calculate the velocity of electron if the velocity of proton is given. So that's all about de Broglie equation. Thank you.